Everyone, for today's lesson, we are going to learn how to simplify rational expressions. Before we get started, though, I would like you guys to complete the warm-up at the top of the page. The warm-up is asking you to write a rational function that meets the following criteria. It has to have a range that is all real numbers except -2 and a vertical asymptote of x equals 0. I would like you guys to please write your equation and then explain why your function meets this criteria. I'm not giving you any more information than that, so you have some choices on your hands in terms of how and what you want your equation to look like. Please go ahead and pause the video, and then when you have your equation and your explanation, please go ahead and restart the video, and we'll see how well you did. All right. So I was very intentional in the fact that I did not tell you what I wanted the structure of your function to look like. So we know that there are two types that you could have used. You could have used special case, and special case, remember, is y is equal to a over x minus h plus k. And if you had chosen that, we would need our vertical asymptote to be x equals 0, which means that we would want h to equal 0. And since we want our range to be all real numbers except -2, that would mean we would want k to equal -2. We have no restrictions on that, so any a value that you wanted could have worked. So we could have had y is equal to 52 over x and then -2. And that would have been one example. And the reason why that example works is because our k value is going to be the value that will represent our horizontal asymptote, y equals -2, and it is the value that we would restrict from the range. And then we need our denominator to be an x minus 0, so basically an x, in order for our vertical asymptote to be at x equals 0. So that is one approach. Or you could have chosen like a linear over a linear or a quadratic over a quadratic, something where the leading coefficient of the numerator is equivalent to the degree of the numerator is equivalent to the degree of the denominator. We would have a range that would come from y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator equaling -2. So an example would be, this is considered a simple or general rational function. Could be y is equal to -4x minus 7 all over maybe 2x. Our denominator, in order for us to find our vertical asymptote, we set our denominator equal to 0. 2x equals 0, x would equal 0, and there would be your vertical asymptote. And then because the degree of the numerator and the denominator are the same, in order to find our horizontal asymptote, you take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. -4 over 2 is equal to -2. These are my equations, and I'm hoping that your equations differ from my equations but have the same exact characteristics in order to meet the needs of the criteria here. If you have any questions over how to write functions based on given information, make sure that you have a conversation with me as soon as possible. Our learning targets for today are for you to be able to say, I can simplify rational expressions by factoring and eliminating common factors from both the numerator and the denominator. And I can simplify rationals to solve real-world problems. So those are our I can statements for today. And one of the things that I want you guys to note is that everything that we've talked about this year so far we've talked about linear functions, quadratic functions, which quadratics fall into the category of polynomial functions. And those types of functions as well as expressions, we are allowed to add, subtract, multiply, and divide. We've learned all about that. And now we're in a new type called rational expressions. And the division of polynomial functions. So we've already talked about long division of polynomial functions. We've talked about synthetic division of polynomial functions, and now we're going to be heading into simplifying them in their fractional form instead of using like an old-fashioned division sign. And we're also going to talk about them in terms of adding, subtracting rational functions, where you have a polynomial over a polynomial plus a polynomial over a polynomial. And we're also going to talk about how to solve rational equations. So that is where we are heading on this second part of the unit. A rational expression that is in simplified form happens if its numerator and the denominator have no common factors other than the number 1. Everything always has the number 1 in common, but we're going to be simplifying, leaving our answers in their fractional form. Now, in order to simplify rational expressions, the following property applies. If you let A, B, and C be expressions where B and C can't equal 0 because B and C are in the denominator, and we all know that 0 on the top is okay, but 0 on the bottom, no way, then the following property applies. If you notice that you have A times C over B times C, and they both have in common a C, the C's are allowed to cancel away, leaving you with A over B. This only works if the main operation in both the numerator and the denominator is multiplication. If the main operation in both the numerator and the denominator is not multiplication, then what I just did there does not work. This is probably the most important statement that I can give you guys. A lot of kids will make random errors because they will start canceling when they're not allowed to because the main operation is not multiplication. So this only works if the main operation is multiplication. So if I give you the fraction 15 over 65 and I asked you to simplify, well, what you would want to do is you'd probably say, hey, I know that they're both divisible by 5, and you could, in your brain, just divide both the numerator and the denominator by 5, or you can write it out as 15 is 3 times 5, and 65 is 13 times 5. The main operation in both the numerator and the denominator is multiplication, so you'd cancel away the 5s, leaving you with 3 over 13 as your answer. Essentially, you would divide out the common factor of 5. Over here, working with polynomials, if it's in factored form, and the main operation, which this is 4 times a parentheses, and parentheses times parentheses, the main operation is multiplication. Although you do see addition and subtraction, that's not the main thing that's happening here. What we notice is that they both have in common an x plus 3, the top and the bottom do, and you're allowed to cancel those away. And you will end up with 4 over x minus 5. So you would divide out the common factor of x plus 3. So when it comes to simplifying rational expressions, usually it's done in about 2 steps. The first step, of course, is to factor the numerator and the denominator. So they always have to be in factored form. And we always want to leave our answer in factored form as well. So x squared and 7x both have in common an x, with the leftovers being an x plus 7. And our denominator, you're welcome to leave it as an x squared, or you can write it out as x times x. That's completely up to you. The next thing you want to do is you're going to want to divide out or cancel, is another word. Divide away or cancel out any common factors. So in this problem, they both have in common an x. So I'm going to cancel away an x. And when I do that, I am left with x plus 7 over x. Now, students might say, well, Miss Olivero, can't I just cancel out the x's? And the answer in this case is no, because the main operation in the numerator now is addition. So you cannot cancel. The only time when you're allowed to cancel is when the main operation, the main thing that's happening there, is multiplication. So you have to be really, really careful and ask yourself, is it appropriate to cancel? Or do I have to leave the answer the way that it is? So I'm going to write this down, and although none of these examples will require their answers to be in factored form, we always leave all answers in factored form. After you simplify. So you're going to simplify, and after you simplify, if it's already in parentheses, we kind of leave those parentheses. So always leave answers in factored form. Do not multiply them out. Math apps will do that for you, and that's not the way that you want, that's not the approach that you want to practice, especially for where we are heading in this class. Now, this is one of my favorite lessons, and I absolutely love it because whenever I divide away or cancel out common factors, I always have like a sound effect in my head. And looking at example number 1, I have 2 times x plus 1 all over x plus 1 times x plus 3. And I can notice that these two have in common the x plus 1s. So since the x plus 1s cancel away, we are left with 2 over x plus 3, and that is our answer. Let's go ahead and look at number 2. Now, x plus 4 cannot be factored, so I'm just going to write x plus 4. But now that we've gone so far with our factoring, I need you guys to be able to recognize that x squared minus 16 is a dot. It is a difference of 2 squares. It is an x plus 4 times an x minus 4. And technically, the main operation in the numerator is not multiplication, but if you want, you can rewrite it as a parentheses times 1. And looky there, they both have in common an x plus 4, and they divide away, they cancel away, leaving us with 1 over x minus 4. And finally, here is example number 3. I am going to factor the numerator into 2 parentheses, and I'm going to factor the denominator into 2 parentheses. We are now sophisticated math folks. We can recognize that x squared minus 8x plus 16, this is a perfect square trinomial. And that perfect square trinomial will come from x minus 4 times x minus 4. You can write it as x minus 4 squared. There's nothing wrong with that. Down here, we have to figure out what 2 numbers multiply together to equal negative 24 and together add to equal 2. And that is a positive 6 and a negative 4. So now, as you guys can see, and you guys are anticipating, the x minus 4s are going to cancel away, and our final answer is going to be x minus 4 over x plus 6. All right, let's go on to the next page. The next page is a page that I'm going to do 100% in class. So what you'll see at the top are all of our team pair solo questions. Please go ahead and try these questions on your own. And then I'm also going to do the real world application problem next time I see you as well. So that means that this is the end of the lesson. If you guys have any questions over anything I just talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.